In this video, we will discuss how to determine the amount of significant figures in a measurement. So before we get to significant figures, we need to discuss different properties, and one would be a qualitative property, and another would be a quantitative property. And a qualitative property describes a characteristic in a non-numerical way or a non-numerical manner. And there's plenty of different examples of a qualitative property, and one example could be something like smell. A quantitative property, and I'm just going to copy this, describes a characteristic, but it's going to do so in a numerical manner. And so this would be something like mass, density, and there could be a lot of others. And a good way to remember the difference is that a quantitative, the word quantitative has the letter N in it, and so that kind of is a clue that it is dealing with something in a numerical manner, so putting some sort of number next to it. Now, accuracy versus precision. So accuracy is going to deal with how close you are to the correct value. And it could be the correct / the accepted value, because sometimes we might not know the correct value exactly, but there's an accepted value. And then precision deals with how close you are every time, and so I like to word it how consistent. How consistent your values are. Okay, and so if we look at this first dartboard, and we're going to assume that being close to this center is going to be accurate. And so none of these darts are close to the center, so they're not accurate. Okay. In the second one, none of them are really close to the center, so they're not accurate. In this third one, they're pretty close to the center, so I guess we'll call that accurate. And then in this last one, we're definitely accurate here. Okay, now let's talk about precision. Precision is how consistent your values are, or are your darts, are they kind of in a group together? Okay, because if they are, then you are really consistent with where you threw your dart. And so I would say this first one, they're kind of all over the place, and so that would not be precise. So this is actually neither accurate or precise. Here they're kind of bunched up, so I would say that this is precise, but we're not accurate. Okay, here we're close to the center, but they're kind of spread apart, and so I would say this is accurate but not precise. And then here they're all very consistent, and so this is accurate and precise. Okay, so that's the difference between accuracy and precision. And when we make measurements, we can only be so accurate, and how accurate we are, or how precise we are even, deals with how many markings are on the measurement device that we're using. Because if we have a lot of really small markings, then we can be very accurate and very consistent because we have the markings to do so. But if the markings are not really there, or not there's not a lot of them, then it's going to be more difficult to be accurate and precise. So the rule is that when you record any measurement, you always estimate the last digit. And measurements can only have one uncertain digit, and this is going to be your estimated digit. Okay, and so that estimated digit will go one past the smallest marking, and we'll see an example here. And then for electronic devices like a scale or something, a pH probe, which we'll use later in the year, that last digit will be estimated by your actual device, and so you won't have to do that. So that'll be kind of nice. Okay, so here's what we want to look at is we have 4 and then 5. Okay, so our dial is somewhere in between 4 and 5, and so this must be 4.1, 4.2, 4.3, 4.4, 4.5, and so on. And so we are past 4.3. So these are certain digits. And I know that because I have the markings to help me. But there's no markings between 4.3 and 4.4, so I can't really tell exactly. I can't tell with a great level of certainty what that next digit would be. And so I'm going to estimate. I'm going to say, and I might do it in red here, that this might be about halfway. And so since the dial looks like it's not yet halfway, I might estimate this to be 4.33, and then the units is PSI, or pounds per square inch. And so this is going to be our uncertain, or our estimated digit. Okay, now this last one could really be it could be 4.31, 4.32, 4.333, or 4.35. It could be anything in that range because it's estimated. And so one person might estimate it something completely different than someone else. The thing that's important is that measurements can only have one uncertain digit, and that you go one past the smallest markings. The smallest markings on this were the tenths, and so I went out to the hundredths. Okay, so again, this could be, we know that it's at least 12.6 something centimeters, and since our tenths here are certain, we want to go out to the hundredths, and that looks like it's that more than halfway between 6 and 7, so maybe I say that that is 8, but again, that is variable, but the fact that it goes out to the hundredths is not. Now, when you read some sort of liquid, you want to make sure you read the bottom of the meniscus. Okay, so that's going to be, and that wasn't a very good, let's do this. Something like there, okay? And then what a lot of people do is they kind of mix this up. The big lines are your 5s. So this is 35, 36, 37, 38, 39. So this looks like it's between 36 and 37. So I know it's 36 point something. I don't have any tenths to help me out. It actually looks like it could be pretty darn close. So I'm going to say that this is 35 or 36, excuse me, 36.5 milliliters. Okay, and you'll actually do something like that a lot. Again, this last one could be 4, 5, 6, 7, something in that ballpark, but we just go out to the tenths. I'm going to skip this next page. We'll do this one in class. And the main reason for this video is I want to go over significant figures rules, because what we're going to want to be able to understand is, what do we do if we, let's say, take something that was measured in a device like this, where we have a lot of markings so we can be very accurate, very consistent, and we add it to something that was measured in a device like this, where we have very few markings. Okay, and when we combine measurements, we can only be as good as the worst measurement device that we had. Okay, and so I'm going to go through the significant figures rules. We'll come back to why this is important at a later time, but we want to make sure we get our rules down. And so our rules are that significant figures should always have units. Any non-zero number is significant. That is important. Any zero between non-zero numbers is significant. Any sandwich zeros are significant. For a non-decimal number, all zeros to the left of the decimal but to the right of the last non-zero number are not significant. That is very wordy. I don't want to focus on that right now. We'll see that there's a better method than this. For a decimal number, all zeros to the left of the decimal but right to the last non-zero number are significant. Again, that's wordy, okay? Any zeros leading a number are not significant, okay? We'll see the importance of that. And then the last number, or the last rule, is that any zeros to the right of a non-zero number and to the right of a decimal are significant. Again, that's very wordy. Okay, so I can get with rules number 1, 2, and 3. They make a lot of sense to me. And then when I get through 4 through 7, I read it, and I kind of get a little bit confused. So I want to show you a better method that has all the rules, but we don't need to be so wordy about it. And the one thing that it requires is that you know a little bit of geography. So we have the wonderful United States. We have our Pacific Ocean, and we have our Atlantic Ocean. And for the purpose of significant figures, we're going to call this the decimal present ocean. Okay, so hopefully you see the P's are lined up there. And then over here, we're going to call this the decimal absent ocean. And so what all this gets into is where a decimal place is. And so how these rules work is that if a decimal is present, you will start counting from the Pacific side, starting with the first non-zero number. You're always going to start with the first non-zero number. Okay, and then if a decimal is absent, you will start from the Atlantic side or the absent side, and you're going to start at the first non-zero number. Okay, and then if a number is in scientific notation, we'll just ignore the times 10 to whatever power. That's not really important with significant figures. Okay, so what we're going to do is we're going to say in number 1, that's where we'll start, is the decimal present or absent? And I would say that it's absent, so I need to start on the Atlantic side, and I need to find my first non-zero number. That would be 4. And then I need to go to the other side. Anything including and after 4 is significant, so I think that this has 4 significant figures. On number 2, is the decimal present or absent? The decimal is present, so we need to start from the Pacific side, and I'm going to start traveling to the other side until I hit my first non-zero number, which is 2. So what that means is anything including and after 2 as I'm traveling is going to be significant. And so that gives me 2 significant figures. On number 3, is decimal present or absent? I think the decimal is absent, so I'm going to start on the Atlantic side, and I'm going to start traveling until I get to my first non-zero number. That would be 9. Anything including and after 9 is significant. So what that means is that we have 2 significant figures. On number 4, let's see how this is a little bit different. Decimal is present, so we need to start on the Pacific side, so I'm traveling, and 8 is my first non-zero number, so everything including and after 8 is significant, so that is 3 significant figures. When I get to number 5, decimal is present, so I need to start on the Pacific side. I keep going. 8 is my first non-zero number, so I have 3 significant figures. On number 6, I have no decimal present, so I'm going to start on the Atlantic side. 1 is my first non-zero number, so I will travel, and I have 3 significant figures. On number 7, I have scientific notation. I'm just not focused on the times 10 to the minus 8. I start on the Pacific side, and my first non-zero number is 4 and 7, and so 2. Any number, if you go back to our rules, any non-zero number is significant. So that does not surprise me that I have 4.7, so I should have 2 significant figures. Okay, number 8, no decimal is present. So I'll start on the absent side, and I'll keep traveling until I hit my first non-zero number. That'll be 5. Everything including and after 5 is significant, so that has 3 significant figures. And then in number 9, decimal present, so 6 will be my first number. That'll be 3. Decimal present, 5 will be my first number. That'll be 3. What I'd like you to do is I'd like you to do the rest of these and then check with the key online. Okay, just all the way through number 42, and then you can stop.